in athletics, but that'll be the goal. Alright, so again, today we're going to work number 2 off of topic 1, the free response. And the assignment for you will be pick one of the other 3, 1, 3, or 4 to do, and then all the multiple choice, but we'll do the multiple choice in class together. So, number 2, with calculator, as these usually are, because you get weird stuff and you want your calculator to handle all the terrible integrations. So, f of x equals 2x times 1 minus x. G of x equals 3 times x minus 1 times square root of x. So already this is looking terrible, but we have a calculator, so we'll be okay. The graphs of f and g are shown in the figure, so they even are kind enough to give you the graph, even though you've got a calculator. And they tell you which one is which. So you don't have to worry about, I guess maybe so that if you're worried about scale, or would you see this if it's just going 0 to 1, how do you figure out which one's on top, which one's on bottom? Like they took care of all of that for us. So at least that was nice of them. Find the area of the shaded region enclosed by the graphs of f and g. Well, that's about as easy as a question as you can get, especially with the calculator. So the area would be top minus bottom, dx, so we'll go 0 to 1. So 0 to 1 of f of x minus g of x dx. So that's showing my work. Now I'll let the calculator handle the yucky stuff. Again, this one I'm pretty sure I want to put in for y1 and y2 because I'm probably going to be using f and g the whole problem. Alright, I guess I don't have to look at the graph, but okay, so yeah, that's pretty close to what they gave me. If I played with the scale, I can make it look more like what they gave me, but I don't want to mess with that. There's not a way to find the area between those two on the actual graph like we did yesterday. Like you can do area from the graph down to the x-axis, but you can't do between curves on the picture. So we'll need to do Math 9, 0 to 1. Maybe I need to write down which one is which. I don't need to do that for the grader, but maybe just for myself. Who's y1 and who's y2. That takes a little bit of thought there. To 3 decimals, that would be 1.133. That's as close to free points as you get on the AP test, I feel like. Area between the curves. Part B. Find the volume of the solid generated when the shaded region enclosed by the graphs of f and g is revolved about the horizontal line y equals 2. So I'm going to have this, I don't know if I wanted to redraw the picture or not. So 1, 2. Again, I don't have to redraw the picture, but maybe it's worth it to try to visualize what's going on here. So this is definitely a washer problem. We've got an inside radius and an outside radius. I mean, do you want to take the time to make a super detailed picture? Probably not. Do you want to take enough time to draw enough so that you understand what's going on? For sure. So washer. And again, you don't have to explain everything to the grader, but maybe it's more just helpful to yourself. So I'm going to add up the washers from 0 to 1. And these are dx slices. So just big picture, that's big R squared minus little r squared. Let's see, we're big R. Let's see, top minus bottom for big R would be, the top is 2. And the bottom is g of x, or y2. So the integral from 0 to 1 of 2 minus, you know what, I'm going to call it y2. If I've said that y2 is equal to g and y1 is equal to f, then this is showing my work. I can do that. Plus it mirrors what will go in the calculator, so maybe that's an easier way to do it. But don't do that unless you've told them what y2 is. Otherwise they don't know. I mean, they do know, but they can't assume. They can't read your mind. You need to tell them what that is. Little r. So from the center to the inside radius, little r, again, top minus bottom, so that'd be 2 minus f of x, or y1, 2 minus y1 squared, dx, don't forget the pi, because we're making circles, so we're adding up all the big circles minus the little circles from 0 to 1. My guess is getting that far probably gets you 2 out of 3 points on that problem. Don't forget the pi, note to self. And then now it's just a matter of being very careful with the calculator. With parentheses, so 2 minus y2 squared minus 2 minus y1 squared dx. That might take a little bit for it to think. So my volume is 16.179. And there wasn't anything about units on this, so I don't have to worry about units. Scoring. Let's look up scoring when we finish, then we'll see how well we did. I would hope that you could get parts A and B. Like part A, easy. Part B, medium, because there's a lot going on, but it's a washer. We've done washers. Outside, big R squared minus little r squared. Again, you get the basic stuff, you make a 3, you get a little more stuff, then you start making a 4 and a 5. So C is probably the extra stuff that's going to push us into the 4 or 5 range. Let H be this function, kx times 1 minus x, where x is between 0 and 1. For each k greater than 0, the region, not shown, enclosed by the graphs of h and g, which we really don't know what h is, but okay, I mean, we don't know what the graph looks like. There is a value of k for which the volume of this solid is equal to 15. Write, but do not solve, an equation involving the integral expression that could be used to find the value of k. Okay, so from 0 to 1, I know what g looks like. I don't really know what k looks like, but I do know that at x equals 0 and x equals 1, it's equal to 0. And if I'm really thinking carefully, it looks like a upside down parabola, that minus x squared in there. So I don't really know what's going on here, but it looks something like that for h of x.
Isn't it just the f of x function with a different constant?
It sure is, yeah. So it definitely looks like f of x. It's just it's got a stretchy constant on there that might make it taller, or really tall, or maybe shorter. So that depends on what x is. So yeah, it is the same, or not. It's related to f. Like if k is 2, then it's f. Okay, so there's some volume. The base of a solid with square cross sections perpendicular to the x-axis. All right, we like square cross sections because adding up squares is easy. So I'm going to add up the squares from 0 to 1. Again, that's my attempt to draw a square coming up out of the page there. We're going to add up all the squares. Squares are easy. That's just s squared. And s for this picture would be, anytime you want a length on a graph, it's always top minus bottom. Top graph or line minus the bottom one. So that would be h of x minus g of x. Now, what's it say? So that's the volume of that enclosure, the volume of that solid. That's the generic word we're looking for, the solid. There is a value of k for which the volume of this solid is equal to 15. Okay, so I want 15 to be the volume. So I'll integrate 0 to 1. H of x minus g of x squared dx. Don't know that would get us full points because there's not a k in there yet. I mean, not explicitly in there yet, like it's hidden within the h. So I'm not sure that this would get us full points. So h of x was kx times 1 minus x minus. Now g of x doesn't have a k in it, so I could probably leave g of x as is. But I'll write it out because I don't have to solve it. So there's the equation to solve to find what k is. And fortunately it tells me, write, do not solve an equation. Got that. Involving an integral expression. Yes. It could be used to find the value of k. So yeah, that would be terrible to try to do all that, but it didn't ask me to do it. It just said set it up. All right, just a complete guess on the point values. I mean, we could look it up, and it's out there. But I would guess that 2 is for the first problem, because that's really easy. And so it's probably 1 for the setup and 1 for the answer. B was a little bit harder, so maybe there's 3 points to that. Probably 1 for recognizing that it's a washer with a big R and a little r. Probably 1 for the right big R and little r. Whoops. 1 for like both of them. And 1 for the final answer. So hopefully we get 5. That sets us on track for a 3. And then maybe the last one has 4 points associated with it. Who knows how they divide it up. Probably 1 for getting a kind of a generic volume formula going. Sometimes it does like a point even for getting the limits right. So a point for the limits, a point for h minus g, and maybe some overall point for setting it up right. So even if you weren't sure about C, maybe you could finagle your way into a couple of the points, and maybe you get out of number 2 with 6, 7, 8 points. Should be nice. It's only 3 for part C. Okay. Where was the other point? What did I miss?
So there was 2 for part A, 4 for part B, and 3 for part C.
Okay, so someone looked it up. It was 4 for part B and 3 for part C.
You get 1 for the correct limits and having the constant of 5. And then 2 for, it says integrand.
Yeah, so what you're integrating.
And then 1 for the answer.
So 2 for integrating the right stuff, so getting the squareds and the 2 minus y's and that kind of stuff. And what it said, 1 for the pi and the limits. Limits and constant. 2 for the integrand, 1 for the answer. So that's good. That means you should get 6 points out of there. And then maybe you sneak another point out of the bottom one and come out with a 7, 8, maybe even a 9. So again, they're hard, but they're not impossible. It's set up where if you know the standard stuff, I think you make a 3. If you can squeeze out a little bit more, then you can get yourself into a 4 or a 5. All right, the assignment today is to pick one of the others, 1, 3, or 4, and pick one, not the number 1, but pick quantity 1. Do those, and then due Friday is this packet. All right, what we're going to do in class today is the multiple choice part.